Right, I'm going to take you through a possible solution to the trial SAC for Module 3. I've just opened up a new project, called it Trial SAC Mod 3, and there's a form there for the moment. It's pretty simple. All it's going to do is read some data. You'll need to add the data file to your project, so it's in Documents, VisStudio 15 Projects, where is it? Trial SAC Mod 3. And if you have a look at the way the files are organized, this is where it's actually running from. It's actually running from the debug folder for the moment. But when we do a release file, there'll be a file next to here, a folder called release. So I'm putting the voter data folder, which is just a CSV file containing, in this format, name, separated by a pipe, age, separated pipe, and a medical condition, a Boolean value, or not a Boolean value, but yes or no for a medical condition. Then you'll need to put that next to the debug folder. So it's inside, if we go up one level, it's inside the bin folder next to the debug folder, or just in the bin folder there. All right, so if I double click on the form, I'm going to get a form load object there, and that's where I'm going to actually read my file. You need to add this directive first using system.io, because we're going to do some file input, maybe some output, but definitely some file input. We'll have to add that library there. So I'm going to actually just first of all read the file. Now I'll need to have a path to that file. Now if you've done any DOS programming before, you'll understand the next part of it. So I'm just going to do file path, str file path, and it's going to be, start with the @ symbol, and I'm going to use 2 dots because it's going to be one file level, one folder level above. The 2 dots followed by the \, jump from inside the debug folder out to the next level. If I didn't have those in there, it wouldn't find the file because it would be expecting to see it in the same folder the application is running from. And I've called it voter data, haven't I? Voter data, and you've got to put the CSV suffix onto it. Okay, there's my file path. So in my form load, I'm just going to have a comment here, just read the voter data file and store records in data structure. So we want to actually read the file, store the data, then close and do some processing later. So what we'll do is we'll actually, well, let's have a look at the file IO first. So if I look at the file object, and there's a lot of methods we can use in there for reading and writing or appending. We want to do read. Now there's read all bytes, all lines, or all text. All text reads one line. We want to read all possible lines there. I think there are 100. So if we double click on that, what we'll find is it needs a file path. It needs a file path, and it returns us an array of strings, importantly. So the file path we've got up there, so it's just going to be str file path, right? And that will return us an array of string with every record, every line as its own string in the array. So if I put string array, and let's just call it lines, let's go have a run it and have a look at what that will return for us. So remember that while we've got an algorithm that says while not end of file, read, process all the data, that's an algorithm. It doesn't necessarily reflect how you would implement it in a particular language. File read all lines for us does all of that. It reads every line, opens the file, reads every line, and then closes the file for us. You can actually read through that. So if I, let's put a stop point there and a debug point, run it and see what happens. Okay, so if we look in the lines, it says there it's got 100 string items in it, and there they are. There's our string items there. Grace Z. Sanders, she's 33 and has a medical condition, and so on. There's right down to 100 of those. So there you go. They're all red. But what we need to do now is actually process that each one of those file items, those line items. So we're going to use a for loop for int I equals 0, I is less than lines dot length. We're going to step through every item in there and process it. So what we need to do now is get each line one at a time and break it up. Now we know the format of our file is this. It's name, separated by pipe character, age, and you shouldn't use age, you should use date of birth and calculate the age based on the current time, name, age, and medical. That's the format of our file, a CSV file. And each record is on a new line. So each record at the moment is stored in there. So what we're going to do is actually go and process each record. Now we need to pull it apart, but let's go and get each line one at a time. So let's get a string and call it line, and line equals lines, oops, I. Okay, that will go and get us one line at a time. You know this, you know how to step through an array. So this goes from 0 to 1, less than the length of the number of items in lines, and gets us one item at a time. If we ran that again, we'd see that we get, well, we're down to the last one, aren't we? So that will, you'll have a look in here. Oh, it's actually gone out of context. So if we run that again, you'll see that each time we run this through, right, there's our first line, there's our second line, and so on. So it's picking up, we're stepping through each line, we're iterating through each item in the lines array. What we want to do now is actually break that down and store it somewhere. Well, that's not too hard, but we better create a data structure to actually store things in. So let's go and create a struct, create a record. Let's call it voter record, and it's going to have 3 public items in it. Public string, 3 fields in it. String, bad typing day. Name, public, int, age, and public bool, medical. Alright, there we go. Alright, so there's our data structure to store each item in. Well, what we do need to do now is actually pull this line apart, because we know that it actually contains name, age, and medical for each of those. Pull it apart and store each item in a new record. So let's create a new record. Voter record, the record equals new voter record. There we go. Okay, cool. Now we need to pull our line apart. Now, most languages contain a function for actually parsing or pulling apart a line, and split is the weapon of choice in most cases. And what it says is, split will give us an array of strings, returns a string array that contains the substrings in this instance. So in the string we pass it, in line or return all of the substrings that are delimited or separated by elements of a special Unicode character. In other words, a separator. Well, our items are separated by a pipe, but that pipe has to be, so let's do this, separator. To separate a character for CSV file is the pipe. Okay, so we've actually got to store that in an array. So you could separate using more than one character. So let's call it separator, and we'll set it to be equal to an array of characters of one pipe. That's it. So we've got an array of one item in there, but it can't just be a character, it has to be an array. Now, to put it in curly brackets makes it an array. We could also, if you wanted to, you could put in, we're going to separate it on asterisks if you wanted to, but we don't have any of those in there, so it doesn't really matter. But you could do that if you wanted to, if you were separating on multi-characters, but we're not, we're just separating on that, so that's cool. So we need to split, but we need to give it the separator character. There we go. And it will return us, if I could spell, that'd be cool, separator, oh man. Right, so if we now, forgive my spelling, that will give us an array of strings. So if I do this, string, array, line items. Right, so if I run that through now, we should be able to see what actually comes out of this. Alright, so here we go. So we've got our lines. It's read 100 of those. There they are, each of those in turn. What we've got now is we read the first line. It's Grace Z. Sanders, 33, and yes. We haven't got, the record will still be equal to null because we haven't actually given it any memory yet. There's nothing going on. There's no age, medical, or name. And now line items. Let's run that on to the next one there. So I'm going to put a stop point there. Continue. Now have a look at line items. It's got 3 items in it. If we expand that, there's Grace's name, her age, and her medical condition. So if we run that on for the next one, I now equals 1. The line is Amity F. Hansen. And if we continue on here, the line items is now showing Amity's age is 64, and no, she doesn't have a medical condition. Okay, so what we need to do now is actually pack that into our record that we've created there. So I'm going to ditch those. And so the record dot name is going to be set to be equal to line items 0, because that's the item that contains the name. We saw that. The record dot age is going to be set to be equal to line items 1, and the record. Now, actually, we're going to find it. We're going to get an error there, aren't we? And the reason is that that's a string, and it says it can't implicitly convert a string to an int. Okay, so we need to use convert. We need to stick that inside a convert dot 2, and we're going to convert to int 32. Okay. Now the other one we know is yes. Now yes is not a Boolean value, so we're going to have to put in a selection statement there. If line items 2, it's either going to be yes or no. So if we can put that equals, and it's capitalized, yes, then we're going to set the record dot medical to be equal to true. All right. Now there's only 2 options, so it's safe to say else the record dot medical equals false. There we go. Cool. All right. So now if we stick a dot point there, stick a breakpoint, and let's run through and check this out. So if we look in the record now, we can see the age, medical, and there's Grace's name. Run it again. The record, 64, false, and Amity. So cool, we're picking up each record. Now what we need to do is actually obviously store those. We could store these in an array. That would be fine. Or we could use a list. Let's use an array. So we'll create an array of voter records, and let's call it voter records, something completely different. Now we don't know how big voter records, how many voter records there are when we create it. So we'll have to come down into here. Now when do we know how many records we've got? Well, after we've read all the lines. We'll know that the number of lines we've got, 100, so we know that we've got to create an array big enough to hold all of those items. So down in here, we can initialize our data structure. So, I beg your pardon, so it's voter records. Make sure you get the right one. It's the instance of it, not the type. So it's lowercase, equals new voter record. Now, how many do we want? Not 100. That may change. We want however many lines we read. Well, that's contained in lines length. So you've got all the data you need to work with, you just have to find a way to apply it. So now we've got a structure of voter records, an array of voter records that's large enough to hold however many items we've read. So what we need to do now is actually store that. So we've created a record. So in here, make sure you do it at the right level. This is inside, this is our for loop here, that's stepping through and unpacking every line that we've read, pulling it apart, creating a record, packing the record, so we need to store it here. So voter records, now to store it, we go to whatever item we're up to in our lines, line 0, line 1, line 2, and we'll go to voter records, whatever I is, and set that to be equal to the record. So we're basically creating a record and storing it in our array of voter records. So if we run that again, this time we should see that inside voter records we've now got one member. Oh, there are 100 items there because we've actually initialized it. But if you look at these, the first one's got Grace's record in it, the next one doesn't have anything. Run it on again, have a look in voter records again, Grace's record, Amity's record. And that will continue till we've read all of the data along. So if I shift that, continue it on. Now have a look in voter records, and there we can go to any one of these and we can see that there's, if we go right down to the 100th, I don't want to do that. But there you go. So, all right. So what we've got is we've read all our data. Now we probably should, rather than put that there, we probably should put all of that into its own method. So I'm going to turn that off. I should have done this to start with. It makes good programming practice. So there's the level that methods have to go at. You can see that level of indentation there. So if I wanted to come up here, I tend to put all of my methods down the bottom. So there's the namespace, there's the class. That's the end of the namespace. You go up to the top there, you'll see that that pairs with that. That's the second one, is the end of the class. Be careful that you don't get your bracketing become inconsistent. So I'm going to create my own method, and I'm going to make it private. Now, this is cool to do for your SAT if you need to read data a few times. And let's call it read voter data file. Actually, it's going to return void. I could make this a little bit more useful, but anyway, we'll just do that. All right, and I'm going to take all of this, all of the stuff that's inside my form1 load method, and I'm going to grab all of that. Don't come down to the last bracket there. That's the end of the load method. I'm going to cut that. So there's the start and end of my form load. Make sure your bracketing remains consistent. Put that in there and paste. Now, I'm going to call read voter data file. There we are. Much cleaner. Does the same thing, but what it means is that now if I wanted to change how I read it, I can just modify this and I don't have to worry about changing the order that things happen. And so read data file. Okay, and I've got my comments in there. I probably should put a comment here for the method, a method level comment. Method to, I call it a function in the language. VCAR speak function to read the contents of the voter data.csv file. Okay, there we go. All right, and you could become more explicit about what information you put there, but it's a pretty simple method at the moment. So, all right, so let's go back and have a look at our form design. We haven't done anything on that. So when on our form design, because our output is simply going to be a bit of text, we're not going to, we could use a data grid to display something, but we're not going to. I'm just going to do this. I'm going to change that text, and I'm going to put eligible voters. And I'm going to change this one to be, I'm going to get rid of the text from that entirely, and I'm just going to put up here output. Okay, there we go. I didn't bother to change the name of this because I'm not referencing in code, but label output will do for this one. And I'll need a button. You've got to have a button. Where's the button? All right, button. And I'm just going to name BTN. It's just going to do some calculations. So calc, I'll do calc voters. I can't remember what it was in the thing, doesn't matter. You'd have to make sure that that's consistent with the layout design, but let's just do calculate. Alright, so there we go, and I can just make that a bit bigger. You can format this however you want. Alright, now I'm just going to double click on that to add a handler for it. So now I've read the data file, so now I've got to go through and process it. The cool thing about the file read is we've actually read all the data, stored it, and the file's been closed, so there's no chance of it becoming inconsistent. So now we've got to process the voter data. And our algorithm goes something like, for each item, for each voter record, if age is greater than or equal to 80, or medical, equals true, then increment count. Increment a counter. Okay, so for each voter record, well, that's just a for loop, isn't it? For int I equals 0, I is less than, we've got it in voter records dot length, okay, I plus plus. Alright, so that's going to step through each of our things. Alright, so there's our for loop. I'm going to put that in, put my selection statement in here. So, if, we better unpack the record first, haven't we? We better go and get that record. So voter, this is reversing the storage voter record process that we did before. The record equals, go and get it off voter's record, off the voter records array. Just go and get every one in turn, stick it in a temporary variable, get every one in turn, stick it in a temporary record, and then we can just see what's going on inside it. The record dot age is greater than or equal to 80, or, beg your pardon, is greater than or equal to 80, or greater than 79. Either way, doesn't matter. It's a preference I'll leave up to you. Or is the two pipe characters, or the record dot medical equals true. Then we know that we're going to have to do increment count. Well, we don't have a counter, so let's just do int count. Oh no, I'll just do count equals 0. Count plus plus. There we go, increment it. So what we should find now is that we've found out how many things. So the last thing was to display our algorithm. So we do lbl output dot text equals. Now we can't count as a variable, is a number, an int, so we just can't do that. So we could use convert, but there's a shorthand way, to string. There we go. That's the same as doing convert dot to string. All right. So let's run it and see what happens. All right. So we've read the data file. Continue. 68. Now, if you want to step through that and have a look at how that works, we've read the data file. You don't need to read the data file. That's all done. So if we have a look at this section here, calculate, so voter records.length is 100, we know that, 100. Count is 0, we can see that. So if we come down into here now, step it on, the record, right, there we are, we've got Grace's record, she's 33, but it's true, because it's the age is less than our tipping point, but the medical is true, we'd still expect count to drop into here. All right, so it's going to increment count Right, next one, if we look at voters, what have we got? The records still equals, right, now equals, what have we got? Age amity, 64 and false, so we would expect that it doesn't drop into count. It would actually, so we'll skip, we won't see it drop down to this dot point. Right, it's gone back up to the top and read the next record. Okay, so that's working. Now, something else we could do is we could actually store the eligible voters if we wanted to in another data structure. So I'll just do that in a list rather than an array, because we don't know how many eligible voters there would be. So we're a bit stuck with that. We can't resize our array, but we can use a list. Now, a list is a parameterized type. So I've got to give it a data type. Let's call it eligible voters. I may as well be consistently wrong. Eligible voters list equals new list voter records. Right. So a list is a parameterized type, so it knows how big each item it's storing is going to be. All right. We couldn't just call it a list because if we were storing integers or something like that, it wouldn't know how big to make it. When we create an array of voter records, it knows how big to make the data structure because it knows how big a data record is. Same with a list. We've got to tell it what kind of items are we storing in the list so it can allocate the right memory space. All right, so now all we need to do is actually come down here. We know that we've found an eligible voter when we increment count. So let's store the record. So eligible voters list dot, and let's simply use as add and the record. There we go. It's as simple as that. And at the end of that, if we came down to here and ran that, we should find that in our eligible voters list, calculate, we should find that we've got 68 records in there. First one is Grace Sanders, the next one is, there you go, so that's all good. Either that has to be true or the age has to be over 80 or above, so that's all good. And the good thing about that is, or the cool thing is that now we've got all of the records of those voters stored. If we wanted to, we could write a file, so let's just do that. At the end of it, let's output, let's just do file dot, well, actually we'd need to do it as we could do that as a method. But anyway, look, I'll leave that. Oh no, we may as well do it. We could just write that out as a file. Look, no, we won't worry about that now. But anyway, that's one way you could go about solving the trial SAC. Okay, cool.